Predicting the exact temperature of Earth in 2050 involves numerous variables and uncertainties. However, climate scientists use models to estimate future temperatures, based on different scenarios of greenhouse gas emissions. According to the Intergovernmental Panel on Climate Change, IPCC, if current trends in greenhouse gas emissions continue, the global average temperature could increase by approximately 1.5 degrees C to 2 degrees C above pre-industrial levels by 2050. This prediction is based on medium emission scenarios, such as the Representative Concentration Pathway, RCP, 4.5. Higher emission scenarios, like RCP 8.5, could result in even greater temperature increases. Causes of temperature rise. 1. Greenhouse gas emissions. The primary driver of global warming is the increased concentration of greenhouse gases, GHGs, in the atmosphere, primarily carbon dioxide, CO, methane, CH, and nitrous oxide, NO. These gases trap heat from the sun, causing the Earth's temperature to rise. 2. Deforestation. Forests act as carbon sinks, absorbing CO from the atmosphere. Deforestation reduces the number of trees available to absorb CO, leading to higher atmospheric CO levels. 3. Industrial activities. Burning fossil fuels for energy and industrial processes releases significant amounts of CO and other GHGs. Industrial agriculture, particularly livestock farming, also produces large quantities of methane. 4. Urbanization. The expansion of urban areas leads to the creation of heat islands, where temperatures are significantly higher than in surrounding rural areas due to human activities and infrastructure. Sources of information. 1. Intergovernmental Panel on Climate Change, IPCC. The IPCC provides comprehensive assessments of climate change science, including future climate projections based on different emission scenarios. 2. National Aeronautics and Space Administration, NASA. NASA conducts climate research and provides data on global temperature trends. 3. National Oceanic and Atmospheric Administration, NOAA. NOAA monitors and reports on climate and atmospheric conditions, contributing to climate models and predictions. 4. Climate change research institutions. Universities and research institutions around the world conduct studies on climate change and its impacts, providing valuable data and insights. Implications for human survival. 1. Heatwaves. Increased global temperatures will likely result in more frequent and severe heat waves, posing health risks, especially to vulnerable populations such as the elderly, children, and those with pre-existing health conditions. 2. Food security. Changes in temperature and precipitation patterns can affect agricultural productivity, leading to potential food shortages and increased prices. Extreme weather events can also disrupt food supply chains. 3. Water scarcity. Rising temperatures can lead to reduced water availability in certain regions, affecting drinking water supplies, agriculture, and industry. 4. Sea level rise. Melting polar ice and thermal expansion of seawater due to higher temperatures will contribute to rising sea levels, threatening coastal communities with flooding and erosion. 5. Biodiversity loss. Climate change can alter habitats and ecosystems, leading to the extinction of some species and the migration of others. This loss of biodiversity can disrupt ecosystem services that humans rely on. Human adaptation and mitigation. 1. Adaptation strategies. To survive the changes in climate, humans will need to adopt various adaptation strategies, such as developing heat-resistant crops, improving water management, and building infrastructure resilient to extreme weather. 2. Mitigation efforts. Reducing GHG emissions is crucial to limit future temperature increases. This can be achieved through transitioning to renewable energy sources, enhancing energy efficiency, reforestation, and promoting sustainable land use practices. 3. International cooperation. Global efforts, such as the Paris Agreement, aim to unite countries in reducing emissions and supporting climate adaptation and mitigation initiatives. Conclusion. While the exact temperature of Earth in 2050 cannot be predicted with certainty, it is likely to be significantly higher than today if current emission trends continue. The causes of this rise are well understood, and numerous sources provide valuable information on the subject. Human survival will depend on our ability to adapt to changing conditions and mitigate further temperature increases through concerted global efforts.